Okay, so now we're going to look at what it means for a differential equation to have an initial condition. So let's say we wanted to graph the function y equals the integral of 3x squared minus 1 dx. So we, find the antiderivative. You would get that y would be equal to 3x to the third over 3 minus x plus c, or just x cubed minus x plus c. Now, the problem with graphing this is that we don't have a specific value of c. So even though we can technically, graph x cubed minus x, we need a specific value of c to graph exactly a specific, line. So we, we call this, a family of solutions, a family of solutions or a family of functions. Because there's technically an infinite number of possible values of c, so technically an infinite number of possible values of this function that would satisfy this integral. So in order to graph a specific, function, we need to be given a specific condition. So we have to be told like the point that the graph would go through. So we could say like, let's say the graph goes through, we could say 4, usually be worded like 4 or with the initial condition, 4, 2, 4. So the initial condition is 2, 4. So that means that it has to go through the point 2, 4. So what you would do is then just set this equation with y being 4 and x being 2, and then solving for c. So you solve this, you get 4 equals, 8 minus 2, 4 equals 6 plus c, and then you get c is negative 2. So you get a specific value of c, and so then you can have a specific value of the function. So we could have y equals x cubed minus x minus 2. So we call this a particular solution. This is a particular solution for the point 2 comma 4. And on this graph, you could see like it would be this line right here. This graph you can see up here goes to the point 2, 4. Now you can also see all the other possible functions that this graph would be for the different values of c. C is 4, C is 3, C is 2, C is 1, and so forth. So this shows a family of functions. So let's look at another example. So let's say you're told to find the antiderivative of capital F prime of x is equal to 1 over x squared that satisfies the initial condition, capital F of 1 equals 0. So we find the general antiderivative first. So we set up an integral as 1 over x squared, which is the same as x to the negative 2 dx. We find the general antiderivative, add 1 to the exponent, divide by negative 1 and plus c. So we have the general solution. And so then we then look at the initial condition. This is saying that when x is 1, y is 0. So it has to go to the point 1, 0. That means that the y value, or remember y, let's remember this in general just so we are clear on what I mean. So we have y equals negative 1 over y equals x to the negative 1 over negative 1 plus c with the initial condition. That means when y is 0, x is 1, so we would have 0 equals 1 to the negative 1 over negative 1 plus c. 1 and the negative 1 is just 1, and this is just going to be negative 1. So we have 0 equals negative 1 plus c. And then so c is equal to 1. So now we know a specific value for c. We can write our particular solution as y equals x to the negative 1 over negative 1 plus 1. This comes up a lot in in science classes, and it's gonna be really useful once you start, getting to like more advanced, integration problems.